All right, so we're going to talk about end behavior today, and you guys are going to learn a brand new notation that you have never done before. That's called a limit. A limit is one of the very first things we talk about in calculus, and a limit just describes what's happening on the graph. And so for end behavior, the limit is always going to either approach infinity or approach negative infinity. So for this first one, you didn't have to word it like I did for 2a, but the y values get bigger and bigger. You say they increase without bound, they get more and more positive, either way. But the x values getting bigger and bigger and bigger. What is the x getting closer and closer and closer to? It's kind of a number, it's kind of a concept. Well, like, what's the biggest number ever? Infinity. So x is approaching infinity. All right, so we're going to write a limit. And so limit starts off with LIM, which you can write cursive or you can write it in print, whatever. This LIM, which stands for limit. And underneath, the x's that get bigger and bigger and bigger is when x is approaching infinity. So that goes underneath the limit. And then after that, you always need to name the function. So our function's name in this case is f of x. And on the other side, we're going to write like how you read this limit, but it's the limit as x approaches infinity of f of x. And then you tell what's happening on the y's. So what is y getting closer and closer and closer to? Infinity. All right, you guys wrote your first limit. All right, we're going to do one for b also. So we're going to start with limit as x approaches. So in this one, the x values decrease without bound, which gets smaller forever. So what is x approaching on this one? Negative infinity of f of x. All right, and then what is the y getting closer and closer to? Also negative infinity. Now, in Algebra 2, use a totally different notation, and that's okay. That's what their standards wanted you to use. In pre-calculus, in AP pre-calculus, they want you to use limits to describe the end behavior. So that's what we're going to do. All right, so let's look at 3a. So this one, the x values are getting bigger, so we're going to say the limit as x approaches infinity. This one is called g of x. And then on that graph, the y values got bigger and bigger, so that's going to be infinity. All right, and then for 3b, it's the limit as x approaches negative infinity of g of x. And then on that one, the y's were increasing, getting bigger, so that's going to be infinity also. All right, questions on writing limits? We are going to get more practice on the other side with that as well. Okay, and then on C, they just made one little change to the function. They changed the 3x to the fourth to negative 3x to the fourth, and that made complete changes to what happened at the end. So instead of from both of them pointing up, it changed to both of them pointing down. And then on number 4, they wanted you to look at those two graphs. We'll figure out which was which and look at them. And the ends do the same thing. So looking at what happened on 3C and what happened on number 4, which term matters when you're looking at the end behavior? The very first term. Now, I'm going to word this. I'm going to add something to it. So it's the first term if the function is in descending order. Which most of the time it is, but sometimes I throw one in there that's mixed up. So you're always wanting to look at the one with the largest exponent. That's the one that matters. Why do you think that matters the most? What did you say?
It determines if it's even or odd.
It does. It does. Then, like, when you're looking at what's happening kind of in the middle of the function, all of the terms matter. So they're going to create maximum and minimums and zeros. But we're looking at what happens when x is close to infinity. The only one that matters is the one with the largest exponent. It's going to overpower all the other terms. All right, so I'm going to find a way to word that with less words. So we're going to say when x is very large or very small, and you raise that to a power, the biggest power is going to overpower. So we're going to say the term with the largest power overpowers the rest. And you might have never thought about that before, but you put a big number into an exponent, it makes it way, way bigger. Okay, so let's fill in the notes. So for very large positive or very large negative, I don't really like that much, input values, which is going to be the ends of the graph, the polynomial behavior is dominated by the leading term, which you guys kind of already figured that out. And so from that leading term, you're going to get two things. You're going to look at the degree, and what matters on the degree is if it's an even degree or an odd degree. So fill that in on your table, please. And you're going to look at the coefficient, the leading coefficient. What matters on the leading coefficient? Positive or negative? Now, for my Algebra 2 students and my pre-calculus students, what I tell them about the leading coefficient might be different from what your Algebra 2 teacher told you. I don't really know. But the leading coefficient, what I remember, is it always tells what happens on the right. So if the leading coefficient is positive, I know on the right side that is going to be pointing upward. So positive leading coefficient, the right side's up. Negative leading coefficient, the right side's down. Now, how do you know what the left side does? That's where even and odd is going to come in. All right, so if the function is in the even degree, so like x squared or x to the fourth, is the left going to do the same thing as the right, or is it going to do the opposite? It's going to do the same. So the left is the same. On odd, the left is opposite. All right, so I'm just going to draw some little arrows on this. Most of the time your answer isn't going to be drawing arrows. Most of the time your answer is going to be answering using limits. But I know for a positive, a leading coefficient, the right side is going to point up. And then if it's an even degree, the right side is also going to point up. The left side, sorry, is going to point up. All right, then if I go over to this box where there's a negative leading coefficient, I know the right side is going to point down. And because it's even degree, the left side is going to do the same. All right, let's go to the second row. For a positive leading coefficient, I automatically know the right side is pointing up. But for odd degree, the left side needs to do the opposite thing. All right, and then negative, I know the right side is down. For odd, the left side is up. Now, in between those arrows, there can be lots of different maximum, minimum values, zeros, all different things in between. But today, we're focusing on what happens at the ends. All right, and then all polynomials, which is what we're talking about right now, have unbounded end behavior, which means that the limit as x approaches infinity of f of x is either going to be infinity or negative infinity. And then same thing as x approaches negative infinity. All right. And I do want to add a little note that when you're finding the limit as x approaches infinity, that's what's happening on the right side. And when you're finding the limit as x approaches negative infinity, that's what's happening on the left side. All right. And then one more thing about these limits, I'm going to write out in words how you read the limit because that's not something you guys have done before. All right. So you would read it as the limit as x approaches infinity, in this case, or negative infinity, of f of x is, and then whatever you get for the value of your limit. All right, and there's one thing I left out. We probably should have talked about it on the first day we talked about polynomials, but we didn't. So whatever day we talked about, like if it's degree n, it has n zeros. We should have also talked about the number of turning points, and I just skipped it. So I'm going to go ahead and put it on this. So if you have a polynomial function of degree n, the most turning points it can have is one less than that degree. So there's a question on your assignment that's like, so something like I don't know, you have to figure out if it's a degree 5 or if it's degree 3, and the number of turning points is what's going to help you figure that out. So like if it's a degree 5, the most turning points it can have is 4. If it's degree 3, the most it can have is 2. It doesn't have to have any. Okay, so here we go. Let's look at this one. Number 1, we have the graph. Let's call this f of x since it doesn't have a name. I like for them to have names. We're going to use limit notation to describe the end behavior of the graph. So I'm going to start on the right side. And the right side is going to be the limit as x approaches infinity of f of x. So when we're doing it on a graph, it's fairly simple. I think you just look if that is increasing, if the arrow is pointing upward, then that's going to be positive infinity. All right. And then the left side is going to be the limit as x approaches negative infinity of f of x. What do you guys think? Positive infinity or negative? Should be positive infinity. So on the left side, the arrow is also pointing up. Even though you don't see an arrow, it's just going up, up, up forever. All right, question? Can't tell from your faces. All right, let's look at number 2. We're still talking about the same graph. Is it possible for this graph to have degree 5?
No.
Why not? You're right.
It's not even. It's not even.
5's not an even degree. Very good. Okay, degree 5. So for the turning points, that is the most it can have, but it can always have less. So the big reason is that this one, the arrows are pointing in the same direction. And if the arrows are pointing in the same direction, it has to have an even degree. So we're going to say no. Odd degree functions have ends that point in opposite directions. So it's definitely an even degree. Could it be degree 2? Could it be?
Yes.
Why not?
No, it can't be because there's 3 turning points.
3 turning points. So most likely, what degree is it? It's probably degree 4. Now we don't really know. Like things could be happening with some imaginary zeros that make weird things happen, but it's probably degree 4 because there are 3 turning points and ends pointing in the same direction. Okay, now I'd never seen questions like number 3 until this year, and I kind of like it. So it says, which of the following terms, when added to the given polynomial, will change the end behavior? So right now, the only term that matters in terms of the end behavior is the negative 2x to the 7th. So if I added negative x to the 8th, would that change the end behavior? It would. It would change the degree. So that's going to, instead of pointing like this, it's going to point like this. What about adding negative 3x to the 5th? That'll change some stuff in the middle. It's not going to change anything on the ends. Okay, what about adding 5x to the 7th? It would, because it would make that leading coefficient be positive, which is going to flip it around. All right, what about 1,000? No. Negative 300? No. So only if it changes the first term is it going to change the end behavior. I should say that more specifically. Only if it changes the first term to either be a different sign or a different degree would it change the end behavior. Okay, and then let's look at number 4. So we want to use limit notation to describe the end behavior. So we need 2 things from this. We need the degree. So it is the degree of y. What do y'all think? We did this on the first day, I think. It's degree 3. So when you're looking at it in factored form, you basically add the multiplicities to get the degree. And for the leading coefficient, we only need to know if it's positive or negative. We can actually tell exactly what it is in this case. Because if I multiplied all this out, that's going to be x cubed and then times that 1/6. It's not always going to be like that. That could have been like a 2x. So anyway, would your leading coefficient be positive or negative? Positive. That's all we need. All right, so you guys try this limit notation on your own. See what you can do. All right, so if you wanted to do a little graph, you can. Or you could look back in the box, whatever. But the limit as x approaches infinity of y, what do y'all think? What would that equal? Yes. And then the other side? Good job. All right, now number 5 is one written in a way to trick you, so don't let it. So we want to know that the graph of f has the same end behavior as one of those 4. So look at f very closely. Which term is the only term that matters for the end behavior? Yes, the negative 5x to the 6. It's written in a bad order, and sometimes they like to do that to you. See if you're paying attention. That is the only one that matters. So what choice would have the same end behavior? Yeah. And it doesn't even have to have a power of 6. It could be any even power. It could be a 4. It could be an 8. It could be a 2. So as long as they have a negative leading coefficient and an even power. They would have the same end behavior. All right, what questions do you guys have?